get constructing a confidence interval on an FRQ for two proportions. So the first thing I want to emphasize is that you need to go back to the state, plan, do, conclude. Really know what you have to do on all those steps. We're asked to use 6% confidence interval to estimate the difference in proportion of parts for these two shifts. This comes from a 2006 AP test. Okay, there were two parts. The first part was to construct this confidence interval. Now, it doesn't say anything about parameters or any checks and assumptions. You have to do that. So the first thing, state. Well, this isn't a significance test. We don't need to state our hypothesis, but I do need parameters are. Okay, so we have two parameters. We have proportion of parts from the day shift that were within specifications and the proportion of parts from the night shift that are within specification. You also need to say what you're trying to do. We want to estimate the true difference in the proportion of parts. Notice I put here how I'm going to this. I mentioned difference. I'm going to do the parts minus the proportion of night parts that are within specification with 96% confidence. That's the state. You're basically restating the problem. I know it's a lot of writing, but get it down. Establish that shorthand. If you're going to use notation like proportion subscript D or proportion of subscript N, you have to define what those variables mean. Next, we have to check for independence and we have to check for normality. It's the same thing, just with two samples. So first of all, for independence, I need to make sure that I not only establish that each sample is independent separately, but that the two shifts are independent of each other. That is extra that you have to do with two proportions. So I have to mention that the two samples are independent of each other. I have to mention that each sample is a random sample of parts. It's also helpful and safe to just say that 200 is less than 10% of all the parts from the day or the night shift. Both of the sample sizes were 200, and our sample size is less than 10% of the population. Then we need to check for normality. This is proportions. Don't forget that. Checking for normality for proportions is different than with quantitative data. This is categorical data. So I check n times p is greater than or equal to 10, and times 1 minus p is greater than or equal to 10. I have at least 10 successes and failures from the day shift and from the night shift. With conditions met, I can construct a two-proportion z-interval with 96% confidence. That should be the hardest part, right there. Getting all of that written down on the paper. Be confident in these things. You've established that it's two proportions up at the beginning. You know you're working with categorical data. These things should just come naturally if you are practicing. Okay, so now let's go to the do. We've done the state. We've made our plan. Do. Now, in your formula packet, it has a rough outline for how to construct a confidence interval. It says statistic plus or minus the critical value times the standard deviation of the statistic. You have to know that your statistic is the difference of the two sample proportions. Then you have to know that because you're working with categorical data, your critical value is a z-star. And then you have to know that because you are constructing a confidence interval, you have to use p-hats for your standard deviation. We do not know what the population proportions are. We're using p-hats in our confidence intervals. Our confidence intervals are always going to use sample information, sample data for the standard deviation. So the only thing I don't have from the problem is the z-star. So I use this 96% confidence interval to calculate z-star. I also have to use my calculator. If I go to second vars, inverse norm. Inverse norm always uses area to the left, so notice I'm actually typing in 0.98, or I could also type in 0.02, and I get my critical value, which rounds to 2.054. I plug these values into my formula, and I get my confidence interval. Remember, you can also go to stat. If you're running short on time and you don't have time to do these calculations by hand, go to stat test. If you scroll down, you have a 2 proportion z, that is a 2 proportion z interval. It asks you for the number of successes. Well, our day shift had 188 out of 200. Our night shift had 180 out of 200. Our confidence level is 0.96, 96% confidence. We calculate, and my calculator does give me the exact same, little bit of rounding error, the exact same confidence interval. This also serves as a good check. If you have the time, you can show all of this by hand, which I encourage you to do. You can get a P just in case you put something in wrong, and then also check in your calculator. Now we have to interpret this. What conclusion? Conclusion of our confidence interval is we are 96% confident. True difference in the proportions from the 2 shifts falls within this interval. Now this is the only part you have to write for the conclusion. But a lot of questions on the AP exam, a lot of FRQs will extend the question by asking you to interpret the confidence level. The confidence level is interpreting the 96%, not interpreting the interval. Our conclusion is that we believe the true proportion is between these 2 points. The true difference in proportion is between these 2 values. We're 96% confident in this interval. If I'm interpreting the confidence level, I would say in repeated samples of 200 part sample size, 96% of the intervals will capture the true difference in the proportion of parts within specification from the 2 shifts. This isn't necessary in my conclusion. If you added it in, as long as correctly, you wouldn't get anything wrong. But it's not necessary for the. All right, part B here, the way they did choose to extend this is ask you to interpret, well, is this significant? Well, because 0 is confidence interval, we have no reason to believe that there is a significant difference between the 2 shifts and the parts produced within specifications. We captured 0 in the interval. That means we do not have significant evidence.